Hey everyone, welcome back to the channel, and today we will be discussing another problem from binary trees from our SDE sheet. I'll just quickly check if I am live. Let me show you the problem statement. Yes, we are. Okay, so let us start off another simple problem from binary trees. Give me a moment. Okay, yeah. So what are you given in this question? You're given a binary tree. You have to count leaves in it. Now for that you need to know what are leaf nodes in a binary tree. So let me explain to you. For example, we have a tree like this. Okay, let's take any tree will work. So for example, I have something like this. 10, 20, 4, 15, 6, 7, right? Okay, so first of all you need to know what are leaf nodes. So leaf nodes are the nodes which do not have any children. So these are the nodes having no nodes, no further children nodes, no children. Okay, at max a node in a binary tree can have two children, left node and the right node, right? This is your root node, this is your left and your right node, right? That's how a binary tree is. So now tell me, the nodes having no children are the leaf nodes, and in this tree those nodes will be 15, 6 and 7, right? Is 4 a leaf node? No. Why? Because it has got a right child. 20 has got both child. 10 has got both left and right. So 15, 6 and 7 are the nodes which do not have any child. Again, as I told you, there will be a lot of application of recursion in binary trees. So how are we going to solve this question? You already have the hint. So for example, this is your function height. What are we passing? We are passing the node of the root node of your tree. So let's say node root is what I am passing. Okay. So if there is no node at all, there is no node for a tree. So what are you, now I'm writing the conditions, base case conditions. So if your root itself is a null node, okay, that means if the root itself is a null node, it is not going to have any children at all. I have to return the count of my tree, count of the children. See, the return type is int because I have to return how many leaf nodes are there. So if your root itself is null, you will return 0. Okay. What is the condition? What is the case when you can say that this node is a leaf node? So that condition is if the root's left node is also null and the right node is also null. That is when you know that at least this node is a leaf node, so you can return 1 for that particular node. So if root dot left is equal to null and your root dot right also is a null node, okay, that is also a null node, that is when you know that this node is a leaf node, so you return 1 for that. Now you have to repeat the same things for all the other nodes, right? This is, for example, you got only a tree with only just one node. For example, 10 is the only node you have in your binary tree. So you'll check this condition, root is not null for sure, but root dot left and root, this condition holds true. So you return 1 for this. But I have to do for every node that is present in your tree, right? So what I'm going to do, I am going to do this thing recursively for each and every node. Let's check. So I would like to, you can do here, I'll be writing a longer version of this code, and in actual code we'll write a shorthand way. So for you to explain, let's say I am storing my left answer in this variable named left answer, and for that I am making call to this function by passing the left node of the root. So root dot left, and left node will do the same task that I was doing for one node when it was a root node. Okay, it will do its task and return me the answer Then I'll repeat the same thing because I want to explore right side of this also. I'll completely show you the recursive stack as well. So I'm making call to the function by passing root dot right. Now they will both have their own answers. I want the sum of that whatever leaf nodes you got from your end and whatever leaf nodes you got, just return the total of that. So I will return left answer plus right answer, right? That will be my entire code. Now let's see recursively how this thing is happening. So see, first the call was made for, I'll just take this. See, code is very simple, understanding is also very simple, but you need to know how and where recursion calls are helping you, what is actually going within these, because recursive codes look very simple if you code them, but you need to know what is happening behind it. Okay, one sec. Yes, let's see now. So what is initially happening in your function, you initially passed 10, right? You passed 10 initially to height of 10 was called. Okay, you checked for both the conditions failed, so you go to the left, you make a call to height function again, for, now let me write it in recursive stack only. Let me draw a stack, for example. This is how in stack, this is, I'm just writing h, right? So h of 10 was called, then you made a call to left of 10 and do the same thing for this. Now your root node for this call will be 20, right? You check for the conditions, both don't hold true, then you again make a left call to 10's left, right? You make a call to the function for the left node of 20. Okay, so h of 15 was called. Now when you make a call to h of 15, you check for the first condition, is root null? No, because now my root is pointing to 15. When I check this condition holds true. Why? Because left and right of 15 both are null nodes, correct? It does not have any other node. So from here 1 is returned. Now left answer got its answer as 1, so I will immediately go ahead and execute the next line of code. So this h15 returns by giving its answer as 1 for itself, right? This one I got in left answer, this is my left answer. Now I'll make a call to right answer for right of what? See, this left answer was called for left of 20. Now I will make a call to right of 20. So h of, what is at the right of 26? H of 6 will be called. When I make call to h of 6, height of 6, root node is your 6, right? So this condition will hold true. It will return as soon as I hit the return condition. That answer is returned to the call which made a call to it, right? So that function will get its answer. So this right answer is returned as 1 from h of 6 to which function? To the function h of 20 basically, because 20 had made this call, 20 went ahead and made a call to right answer, and now it itself is giving 1 as its own answer in right answer. So basically I have left answer and right answer. I go to the next line of code by giving the sum of left and right. So this sum of left and right is 2. So 1 plus 1, 2 is returned to the function which made a call to these functions, right? So h20 made a call to 15 and 6, and they both returned their own answers, which is 1 from each side, right? So this one is left answer, this one is right answer. So this 20 now will be returning its own answer, which is left answer plus right answer, which is 2. So it will get removed from the stack and it will return 2 to that function which made a call to it. So 20 was called by 10. So what answer it returned to? 10 from its left answer basically. So when 10 made a call to left side of its node, I made a call to 20 and went ahead with other recursive calls. So finally 20 gives its answer as 2, which will be stored in the left answer of 10. Okay, so I'll go to the next line of code in recursion and make a call to right to the same function for root dot right. What was the root at this point in time? 10. So now h of 4 will be called. H of 4 will, there is no other, what is this? 7. I did not write 7 here. One more node is there, 7. So when I made a call to H of 4, I'll check the conditions. The conditions will not hold true. So I'll go ahead and make a call to left of 4, which is null. So when root is null, basically this answer will return 0 to 4 as its left answer. I'm not writing it here. Then you go ahead and make a call to the right of 4. Okay, you make a call to H of 7 now. So when you are making a call to height by passing node with value 7, you will hit this condition and it will be true. So 7 will return its answer as 1 to 4. Now this will be removed. 4 got its answer from left answer as well as from right answer, and it will return its answer as 0 plus 1 to the function that made a call to H of 4, right? So 1 is returned from here. So finally, if you see the call stack also, all the calls are removed except for H of 10. Now H of 10 will return its answer as left answer plus right answer, which is 2 plus 1 equal to 3. So finally 3 will be returned and it will remove from the stack. So finally you got your answer as 3. Okay. So with this, since the question was really simple, but I just explained it so that even if you are not good with the recursion, not good with the concepts of recursion or how it is working, I want you to be well versed by the time we reach to the good level problems of trees, right? So I hope there are no doubts now and we are done with this. Let me know if you guys have any doubts, and now we will just code, which won't take any time at all. Give me a second, I'll just check. Okay, so moving to the code. The same thing that I told, I will be writing here. You have already seen the code. If root is equal to null, let me make it root because I'm in habit of writing root. If root is equal to null, you return 0. If root dot left equal null and root dot right equal also null, that is when you know it's a leaf node, so you return 1 in that case, return 1. Okay, and then as I told you, I'll be writing the shorthand method. That will be, I'll simply in one line I will return the answer, which is you are making function call for root dot left. Whatever answer you're getting from there, you are adding it to the, again what you will get the answer by making a call to the right side of the root dot right. Okay, that's finally what you have to return. Let us check. Let's submit it. Simple problem and we are done with it. Okay, so that was all for today, guys. See you all in the next lecture. Bye bye and take care.